Okay, perfect. We are live. Assalamu alaikum, everyone. Welcome to today's online conference, which will be very exciting for me and for everyone interested in the field of applied AI. Today's conference will be covering efficiently using LLMs in your apps and securing them with Guardrails. And today's special guest is Azzedine Idir Aitsaid, which he is very special for us, especially. So, Azzedine Idir is
I'd
currently
say.
an LLM engineer in France, our previous technical manager of our club, School of AI Algiers, 5G instructor, author, public learner on LinkedIn, and he loves doing AI. So, Azzedine, it is our pleasure to have you with us, and the stage is yours.
I am truly happy to participate to the AI Summit with this very quick panel of mine. Efficiency, we will talk efficiency and security in LLMs. Thank you, School of AI, for the invitation. First thing first, who I am. I don't need to reintroduce myself. Thank you, Wael, for introducing me. I just wanted to say that I really love the community of School of AI. I really enjoyed my 3 years there, and it gave me so much knowledge and opportunities that I really want to give the favor to the community. Also, the paper I published is about making LLMs learn 5G through fine tuning. So if anyone wants to discuss this topic once on LinkedIn, or you can contact me through our Discord in School of AI. I would be really happy to answer everything. And also you can see my learning journey in LinkedIn as of with 10K followers that I am somehow I am sharing with them my journey. And yeah, I love doing AI and talking about AI, and that's why this presentation exists. So for this presentation, it is split in 2 parts. My objective really through this is to make you interested enough in the topic and all the concepts I will mention. And also I want to make you survive a discussion about LLMs, about guardrails, how to secure them and how to use them efficiently. But promise me to check the resources I will put in the end of this presentation. In the first part, we will discover 6 tools, techniques, and reflections about how to be efficient in the LLM field. Whether you are developing systems or small application or even demos, you need to be efficient. And we will go through all the concepts one by one. And then we will see how to secure your LLM apps using guardrails. It is the concept guardrails. It is a little bit old concept. It was introduced 9 months ago. 9 months is not that old, but in the field of LLMs where everything is going fast, it is a little bit old. So you need to secure your LLM apps from hackers, from people that want to steal your data and that they use the helpfulness of your LLM against you. And yeah, they might be manipulating language, as you can see here. And I invite you to check my challenges that I put in LinkedIn. You can see how to bypass the intelligence of an LLM in order to make it give you maybe some secrets. Okay, so the first technique to efficiently use an LLM is to avoid using the LLM because they cost a lot of money. To illustrate this, I want you to follow with me this use case. Imagine if you want to classify some patient statements extracted from a doctor-patient conversation, and you want to classify them in 100 classes. This is big. So your first move is to ask an LLM. You will write your prompt directly. Okay, this is the patient statement. But don't forget that you will also write inside the prompt all the 100 possible classes inside the prompt. So the LLM will choose one of them. And this is inefficient. But it's okay because you are using DeepSeek, and DeepSeek is cheap and good. So why not? I calculated the cost of one query, typical query for this use case, and it is 0.302. So why not? We are good. We are using LLMs cheaply. So, but this is very problematic. And you will see why. Because if you have 1 million patient statement, the cost will directly increase to $200. And this is really typical in data science. We always want more data. We always want to throw, we always want to know more. The more data, the better. And imagine if you deployed your system somewhere. If your system is in production and it classifies the patient statements, you will be easily multiplying this cost by n. N can be the number of processes you are using your classifier inside your system, or it can also be the number of clients that are using your system. So the cost, even when you are using the cheapest LLM in the market, will fly. So, as you know, LLMs are not AI. And this should be really, really talked about, especially with managers, because they are easily into AI hype and LLM hype. Okay, LLMs are revolutionary. They are amazing entities that can understand and generate text, but they can never replace, in this use case, a strong TF-EDF method to transform text into vectors, coupled with a random forest. You need to use, in this use case, this method, and never even think of an LLM because it's too costly. Okay. We can have a general rule when to use an LLM, and we talked about it earlier. We always need to use an LLM when there is a thoughtful text generation. It can be for creative writing, maybe for code. For example, you want to document some old code, some legacy code. You transform it from code to documentation. And this is by experience. This is the most important tasks where LLM shine. When the text generation process needs to be thought about. It somehow mimic how human can generate text, and never use LLMs in order to make name entity recognition or extraction and classification and other easy use cases. So, okay, imagine if we are indeed in a use case where we need an LLM. As for example, you have a database schema that you want to ask questions about. You have a graph database in Neo4j. You want to answer, you want to answer questions about this database, such as this question. So you need to formulate a Cypher query. Cypher is the language we want to communicate with a Neo4j database with, and it is really as SQL queries. You can see here match, and this is a relation, this is a node, relation, blah, 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 topic, and we want to see this. So this is a thoughtful text generation. If we want an LLM to generate a Cypher, this is a good use case for an LLM. The LLM will understand this database. I need to have an institution. The institution have a name. I don't know. Sorry. Yep. So if you have this use case, you need to start small. And starting small is not a general rule. It's not just like this. You need to start small because inferring GPT-4o is equivalent in energy to having a light bulb enlighten a room for 10 minutes. And this is the equivalent carbon thing that emanates from the GPU, which is really harmful for environment. So you are starting small for those reasons. And the bear here is unhappy because it's obvious that the smallest LLM won't generate good ciphers. And then you think directly to use Grok because it is free, but in this case, you are really rate limited. If your application, if you want to generate ciphers in parallel and a lot of times, you can't use Grok because you will be easily rate limited. You need to generate, you need to call the API just small amount of time in a small amount of times in a short moment. So you decide to get rich. You decide to create an OpenAI account and or a DeepSeek one, and use directly the API, and it works. You are happy, as you can see here, but you are sending your data to third services, which is not really good if you have a use case that is really intern and private. And of course, the last one, you are rich, really, really rich to use Claude 3.7 Sonnet, but you are unhappy because you are seeing your money going away, and you could use a smaller LLM for this task. So, okay, we somehow knew how to choose between an open source LLM and a closed source LLM, and we want to choose an open source one, but which one? In order to choose which open source LLM, you need to directly check the benchmarks. There are some LLM leaderboards out there. You just do a Google search, and you can see people documenting which LLM is good for this use case, with subjectivity, but also with real evaluations. People are evaluating a lot of times LLMs throughout the day. So just be looking at those leaderboards. And if you don't find anything interesting, you can evaluate yourself, your LLM, or check maybe the technical details of the LLM, such as here for Llama 3.23 billion parameters. But most of the time, they don't give the details about the data sources explicitly and in details. So that's why you need to evaluate your LLM alone. In order to evaluate your LLM alone, you need to gather a data set. For example, this is for our use case. So challenge your LLM and collect its responses, and you will have a data set that have the golden output, which is in this case the query, and the LLM generated output. You need to compare between those two. And the most known metrics are not sufficient. Bleu, rouge, bird score are just ways to assess the semantic for bird, and bleu rouge for the lexical similarity of text. This is not sufficient. You need to think about metrics. For example, in this use case, we can execute the cipher, the original cipher, and the LLM generated one, and then compare the results. If the results are the same, then it's a good generation. For example, it can be just like this. And if you want, do your evaluation and publish it online. It is really, really beneficial for all the community and also for your, I don't know, your recruiters in the future you contributed with a nice ad in AI. And this is really impactful. Also, I want to open a small bracket because most of the time when people evaluate LLMs, they make a mistake somehow. They they evaluate the LLM and the output might be something correct, but the format of the output is not is wrong. Is not a correct format. For example, we want a JSON format. As here we want a cipher. The LLM generates the cipher, but we are not parsing it correctly. And this is a real bias to the evaluation. So in order to avoid this bias, we need to output a structured output from the LLM. And in order to use this, I just wanted to show you this amazing function coded by OpenAI. It is in their SDK. It is the beta parse function, and it forces the LLM to output a structured format. We will just go into the details of this function in the next slide. So there are some other libraries that do the same thing, such as instructor. And there's a lot of techniques that are used after the inference. It is not fine-tuning, but it is really clever. I just want to show you in the next slide how it is done. Okay, so yeah, in OpenAI, they use logic post-processing, and I want to talk about constrained decoding. There's also another technique I will just mention here quickly, which is used in instructor library. It basically reiterates on the inference until we have a valid output that is following a schema. We will talk about constrained decoding. I find this very clever. So it is really simple. As you know, an LLM here, just at the end, we are sampling from a vocabulary. And the LLM will output the next token that is most probable to be outputted, So what we do here, we are masking, we create a mask to keep the tokens that are following a certain structure only, as you can see here. And we enhance their probability and we make all the other probabilities of tokens 0 in order to just sample the tokens that follows a certain structure. This is very clever. This is nice. And also, this is 100% accurate. This is 100% compliant. You are 100% sure that the output that will come after the inference is following your format. You don't need to beg your LLM to output a JSON format anymore. Just use this type of functions. You just write structured outputs in a documentation and you will read about it. So let's get back. Let's close our small bracket. And also this was a technique that I wanted to share to be efficient. This enters also in the efficiency. And let's get back to how to choose an LLM. So, okay, what if all the LLMs that I selected are bad? And I have some private data that I want to keep to myself and never give to third-party services. And I want an LLM that is efficient in my task. This question is answered by fine-tuning. And OpenAI knows this. They even provide a whole service to pay in order to fine-tune a version of GPT-4 just for you. And this is done. This is really done by a lot of companies now. And if you don't have money to give to OpenAI, you can hire an AI engineer, and this AI engineer will he will enter a mysterious maze of choosing what to do next, either prompt engineer, either use RAG, maybe fine tune, or totally another paradigm, which is agentic. I have compressed all the knowledge I know that I collected and the small amount of my experience in the field in this small table. I will talk about prompt engineering and RAG, and in the next two slides, I will give you the advice of someone that I really it is our idol in AI. You will see. I don't want to talk about fine tuning and agents for now. So you use a lot of techniques in prompt engineering when you have a task that is really straightforward. You don't want to have a lot of dynamic workflows. You don't want something that is complex. And also never pay a course about prompt engineering. It's not worth it at all. I saw courses about $500 talking about some private prompts that no one uses. It's a scam. Just use your LLM. Try to think how well you need to prompt it. Use the guides of the provider. Llama, Meta just always give how to prompt your LLM nice and good. And also another technique you need to use is to track your prompts. Always have a copy of your prompt that is saved somewhere in order to compare, okay, this have made this accuracy, this relevance, blah, blah, blah. And you need to use RAG when your task needs a little bit of real-time data that you want to fetch in the inference moment during the generation process in order to enhance the knowledge of the LLM, because you are asking something that you are sure the LLM does not know. Maybe something private about your company, for example. Let's go to fine-tuning, and I want to cite Ship Hyun. She worked at NVIDIA. She has a lot of, she is a founder. She works a lot in AI, and she's also the author of 2 books in LLMs, maybe more, I don't know, but the one I know, the AI engineering and ML design systems. Ship Hyun is really good when she explains efficiency in LLMs. So she's talking about fine-tuning here, and she said that it is the last resource. It is never the first step. And you need to use fine-tuning. It is justified to use fine-tuning when you need a deep expertise in a domain. For example, in my case last year, I wanted to make an LLM learn a whole new domain, which is telecommunication. You can apply it to legal domain, healthcare, finance, I don't know, anything new for the LLM, and that is niche, that cannot be found in the public data. Also, you need, maybe you want to make your LLM aligned with a format somehow. You want it to talk like a certain persona, maybe talking like you, or talking like, I don't know, some famous actor, or maybe talking like Trump, the president. So you need data. And also, if you want to reduce hallucinations in the domain itself that you want to use it about, you need also to know that it is costful, but it is worth it. The cost of using fine-tuning, if you already passed all the previous steps we discussed about, you found that you need an LLM, and you find the good LLM you want to choose. If you justify the fine-tuning, it is a worthy step for you. And also, always fine-tune when you have a good amount of data and that is qualitative. I think this is not always true, because you can fine-tune LLMs with a minimal amount of data, and they become nice after. But it depends really on the task, because this is by my experience. Last year, we fine-tuned LLMs to on data that is really small, and the evaluation after we assessed their telecommunication knowledge, and we sensed a big enhancement in their performance in 5G. Next, Ship-Hyun talks about when to use agentic workflows. So agentic workflows are justified when the tasks involve decomposing a complex problem into many subtasks, and each one of them is handled sequentially or in parallel by a specific agent. So you have somehow some inputs and outputs and data that you need to fetch in a certain moment when you are solving your problem dynamically and in the moment of solving the problem. So this is directly when you pop the agentic pop in your head. Agentic workflows needs also tools, needs to talk to APIs. You can also include RAG in your agentic solution. You are free. You can even use humans in your agentic workflows to verify something. You are free. And last but not least, in this efficiency part, I just wanted to really go through the techniques in order to optimize the GPU utilization of your apps. I won't go really deep into the details of this, because we have a break to do after, because we ended the first part and I am tired a little bit. But you can use prompt caching technique in order to reuse the prompt that were already generated if you ask the LLM the same thing. So you don't go to the GPU. You just use directly the prompts that are cached. I can cite here a famous framework, KV cache. You can quantize your LLMs, which mean basically the LLM is loaded in your GPU, in your memory. By this, we mean the weights are loaded in the memory, and each weight, each parameter is coded in a float, is a float. And the precision of the float can be 32 bits. And by quantizing, we mean we just reduce the precision of those bits. So the LLM becomes smaller, but less efficient, maybe. But this is a balance you need to choose. Pruning, we just you directly throw away the amount of weights inside the LLM that are not pertinent. We just make a discovery of what are the most relevant parameters. This is a whole technique alone. It is in explainable AI field. And then we just cut the weights that are not relevant to our task. We can also use mixture of experts, which mean if you have heard of Mixtral, which is a big LLM, but in time of inference, it just uses a part from the overall parameters to make the inference, which is very, very efficient because we are not inferring using all the parameters. And also you can use Grok directly. It is cheap. It is free directly, not even cheap. It's free, but it has a lot of limitations, of course. And also you can even use your LLMs inside your CPU directly, inside your RAM. And this is by using a famous library called Llama CPP, but you lose a lot of precision, a lot of accuracy when you do this. I will take a small break, maybe answering questions on the chat. And the next part is the security part. So if you have some questions, I don't know where to find the questions actually. Well, if you can help me.
Thank you very much, Azzedine.
You're welcome.
So waiting for your questions.
Ask me questions. We can wait maybe 1 minute in order just to have my breath back and I can continue.
Okay.
No one has questions. Or maybe no one is here.
Yeah. So I personally have a question related to like we have seen, for instance, like new technologies emerging in the hardware field that could make like LLMs hosting, or like when you load the model to the GPU of the novel techniques, much more performant, like the GPUs used by Google. I have heard before that Google
Yep.
used, like, they develop special types of GPUs. So I
Yep.
believe, is this a thing like to consider when we want to build an LLM? We don't only consider like the benchmarks and different evaluation techniques, but also like the provider or the cloud service in which the LLM is hosted.
True, this is a very nice remark. Indeed, having this side of hardware exploration is really, really important. But you need to be careful because if it is always related to environment. When someone promises a lot of advanced GPUs, we need to know how much carbon or how much harmful this technology is to environment, because it is a thing actually. OpenAI is somehow emitting carbon compared to countries, and this is dangerous. So if you ask me about a new technology, a new hardware GPU technology, I need to be careful about it. Give me details. Is it environment savvy or not? And this is important. Performance is not everything. Having the having the task completed is not everything. That's why people are using smaller models and classical techniques just to avoid this big problem.
Thank you.
Maybe there are no questions. May I continue? Maybe.
Yeah,
What do you think?
go ahead. Yeah, I believe the second part of securing LLMs would be more of exciting.
Perfect. So the first part was not very exciting.
No, like more exciting. The first part was exciting. The second would be more.
Yeah, it was long. Okay, let's. The second part will be really really fast. I won't talk a lot because in fact, guardrails are very 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 intuitive. It is very easy. It was a thing. Guardrails were a thing before they were a thing, because it's easy to think about having the input of an LLM, as you can see here, checked, and the output of an LLM checked. So it was just the innovation behind this. It was just naming it making a library through it, and a lot of techniques about it. So it is very intuitive. And as I mentioned, there is no general rule about implementing guardrails. It depends very much on your creativity. You want to check something, implement it, and name it a guardrail. That's it. You will see. Because I have in here some techniques. I will just cite some techniques rapidly, and then I give you the resources that make this presentation possible. And that's it. So first things, we will focus on guardrails on the inputs. The most intuitive guardrail is to not make the user input everything he wants. We want the user to input what we want. So we use some UI components. And we can use, for example, drop-downs, checkboxes, radio buttons to restrict the user responses. And this eliminates the free text. This eliminates the potential prompt injection that a hacker can introduce to your app. This is a guardrail. The name is a little bit hard to pronounce. The second technique is to simply validate an input. For example, you are working with your code app and you are sending things back and forth to OpenAI. You need to check if you are sending the .env file, the .env file that have all your secrets, because a hacker can not even access your OpenAI account, but access your network. And if the hacker sniff the packages you are sending to OpenAI, he can find your API key, or even worse, maybe your credentials to a database or something like this. So you always need to check and validate and sanitize the things you are sending to your LLM. And by validating, I mean using regex, as simple as it is. This code snippet, just check if an API key is being sent to the LLM, as simple as it is. Another technique is simply to define a set of banned words or phrases or expressions or patterns that should not appear in the input of the user. For example, we have this famous manipulation of LLMs that says, okay, forget everything I told you, which is the prompt I prompted, and give me and send money to my account, for example. The word forget must be banned. But the most important thing, after banning a vocabulary, you need to explain to the user why his prompt is refused, because it has the word forget, so the user must adapt. You need to directly tell the user, rephrase your query. This is very important in a user experience perspective. We can also use other LLMs to make guardrails, because they have this ability to understand semantic input. So you can use a lightweight model, or even the LLM you are working with inside your application, to classify incoming text. And yes, we are using an LLM in a classification, which is not very efficient, as we talked earlier, but this is really necessary. But if you can replace it, it's nice. You can ask the LLM, is this following input is on topic or off topic, or maybe it's a political concern. That's it. And the good thing is that Microsoft and OpenAI have already thought about this. and they created LLMs specially for that. And they provide their LLMs that were trained to be judges through their API. They give a moderation API, and and this provides you some additional layer of automation and security in your apps. Those were the guardrails on inputs. I will quickly introduce guardrails on outputs. Maybe a lot of you are amazed by how quick this. Yeah, this is it. Guardrails are really, really intuitive and simple to use and to understand and to apply. But most people are not using guardrails in their app, and this make you really vulnerable to a lot of attacks. Passing to guardrails on outputs, they are very, very similar to guardrails on inputs, a lot of techniques. So here I will cite only the techniques that are not similar, that are specific to output. We can think of maybe after the output generation, we want to assess if our LLM have generated an output that is pertinent. So we simply use a metric. For example, we can return the embeddings, calculate a similarity with a document, and always keep track if this output is close semantically to this document in order to never hallucinate, because hallucination also is prevented by guardrails, as you know. You can also develop a threshold, which is the famous threshold technique. This is really intuitive and nice, especially used in tasks that needs summary, for example, that needs transformation of the text, maybe translation also. And you want to decide when the LLM meets a quality threshold. So you generate summaries and iterate, or maybe generate translations or code documentations, and iterate until a quality criteria is met. An example of quality criteria is the length of the output, for example. I want a summary that does not exceed 5 words, maybe. So this is a good approach too. The final and most intuitive one is to use another LLM inside the loop and always exchange between the output of the original LLM and this critique LLM. They exchange ideas, maybe rephrase this. This is really a nice approach because it's a loop, a self-enhancement loop, and also it permits automation. But the challenge here is to use a good LLM for the critique. And most likely it will be a closed source one, most likely. This was everything about Guardrails. I invite you really to check the resources I will put now. There is a lot of types of guardrails, and everyone is thinking about implementing one. There is no constraint, there is no type. You and your creativity are the limits. So yeah, just jump in the field. For resources about everything I presented today, I advise to check everything that Chip Hewen writes. She has this amazing book, a lot of efficiency inside, mostly about LLMs. And this one is about old classical methods. This is very nice. And she has a blog and she writes a lot of things inside. And the articles inside the blog are really interesting and detailed. There is also a course about Guardrails presented by the amazing CEO of Guardrails AI. She introduces a lot of concepts that are not introduced in this panel, and it is introduced by deeplearning.ai, so it's a sure value. There's also a blog, another one, written by NVIDIA, where they present their framework, Nemo Guardrails. It's also interesting. They have somehow a paradigm. They're trying to officialize and make everything in concepts and organized. But yeah. And the last resource is my LinkedIn profile. If you want to have the latest news, not to understand everything, of course, but if you want to have the latest news about AI, you can connect with me, and yeah, we can exchange. And I also post a lot of things about AI. I often also do videos. They are really short, not that like this one. I think I am good. I think it's 40 minutes. Nice. I finished the panel in 40 minutes. This is nice. So yeah, this is it. I finished my presentation. Thank you, everyone. And yep, I hope you enjoyed. If you are seeing this live, let me a comment. And if you are seeing the recording, also put a comment. Feedback is always appreciated. That's it. Hello, Well.
Okay, I was talking. I forgot about being unmuted. So thank you very much, Azzedine, for your great
You're welcome.
presentation. It was very enlightening, as it opened our minds not only about building efficient apps based on LLMs, but also securing them with guardrails. And I
Nice.
also personally recommend people to also follow Azzedine on his LinkedIn. Very enlightening posts, especially like those posts related to the CTF related to LLMs. They were very exciting challenges. So thank you once again. Now we are gonna take a couple of questions regarding the today's presentation. Yeah. So the first question comes from strategies of knowledge distillation and large language models.
The strategy of knowledge distillation, I don't know if there is a lot of strategies. I think knowledge distillation is a strategy by itself, but I don't know if there is a lot of strategies impacted inside of it. But the very, very simple concept behind this is to use a bigger LLM. We call it a teacher that will pass knowledge to a smaller LLM. You can see it really easily if you want to fine tune an LLM on 5G, for example. I always take this example because I did it. I did somehow a knowledge distillation. And you want to pass all the knowledge, all the questions all the answers that was generated from GPT-4. You ask a question, you generate an answer, you take this answer, and you fine tune with this answer and question pair a smaller model. And this smaller model needs to be only expert in one field. So somehow you can see it as a direct transformation, a direct linear function from the weights of a big LLM to directly be directed in a smaller LLM directly. We are taking this knowledge and put it directly in a smaller one through text. And this is distillation. And it's somehow a technique um, to enhance and to lower the memory footprint. Instead of using a big LLM, you just use a smaller one that is its student.
Okay. The next question comes from me, and it says, could fine tuning small scale or small LLMs could give better performance than using like general large language models such as GPT?
It's
And
all it will.
are there like specific cases where like doing such technique could give better results?
Indeed, um, as you know, the bigger models, the closed source models, are always good because they were trained in a humongous amount of data, and their performance, for example, if you take Claude 3.7, its performance in I don't know, in generating Go code is because it is trained on a good amount and also fine-tuning techniques of Go source language, text, of course. But if you want to take a Quen coder and fine-tune it with a very large and high quality data set of Go language, it will definitely outperform. Of course, you need to be really strategic on your fine-tuning technique. You need to have a lot of consideration. You need to consider also the amount of weights and parameters you want to fine-tune. But in a general rule, if you want to outperform a generalistic model, you need to fine-tune. But the challenge is not fine-tuning itself. The challenge is finding good data and the right amount of this data. And the closed source, the providers, the closed source providers are better than us in finding those types of data. Yep. But
Thank
in a
you very
general
much.
answer, it is a good um, it is a good approach to create experts.
Thank you very much. For the next question, do you know any LLM tools that I can use to build an intelligent SQL assistant?
What do you mean by tools? And uh, I assume by tools you mean something that is ready, something
Yeah,
that already.
yeah. She followed her question by tools that can help with database normalizations and other tasks.
Database normalization. I don't know what is this, but I might answer the other tasks question. Maybe query, maybe generating SQL queries. I know a lot of LLMs that are already fine-tuned and that are good in the task, uh, having a question about the SQL data and generating a SQL query. If this help you, it's nice, but I don't understand what do you mean by tool, because we are talking only about LLMs now. So if you find that an LLM here is a tool, I can give you a lot of LLMs that are good in question SQL generation. And you can find them easily. You can just go to Hugging Face and just search SQL in the search and filter by models. and also filter by the most downloaded one, the most used LLM, and voila, you just have your LLM that is ready and nice in SQL. But tools, I never worked on SQL Assistant, so I don't know any. I'm just an LLM guy.
Okay.
But we can keep in touch. We can I can search for you if you want some SQL tools. Just follow me on LinkedIn.
Yeah. So I have a question personally regarding like the safety aspect of LLMs, and like when you have mentioned like when companies or when like companies they have private data set, and they don't like want to share it with others, or like with uh, closed source like companies who share their models. So what they do, they like fine tune like open source models, uh, but like the aspect of like the regulations imposed like by GDPR. Like I've watched like the previous online conference of machine learning, when companies or when like there are some regulations that are imposed on companies to make like the LLM model forget about some aspects or some user specific data. So does machine learning actually exist in LLMs, and is it applicable?
In fact, it is really machine learning is really existing in LLMs, and also, for example, if you can see, just for example, you can see GPT, you can see OpenAI, they always update their LLM knowledge through machine unlearning. From time to time, some informations are thrown into GPT and into their main LLM, and they easily they easily get out this information by machine unlearning. And the concept is very easy. You just instead of applying I will really simplify it at most. Instead of applying a gradient descent, you just apply a gradient ascent for a specific weight, and boom, directly the information is forgotten. And this is really important, especially for closed source LLMs, because we don't apply. I don't think we could apply. Yeah, maybe we can apply it because we we can have an LLM that is open source that has some problems, and we want to make it unlearn some things. So to answer your question, machine learning is applied to LLMs and is needed. In fact, we need to make the LLMs forget about things.
Okay, thank you. So I guess one more question.
Yep. One more question from the chat.
Yeah, I guess like I have personally another question related to multimodal models. So as we know today, like there is new trend emerging, which is vision language models, and I believe this is just like a new field that is emerging, like I said. But does the specific like metrics that you have mentioned when it comes to building efficient apps based on LLMs, apply to vision language models or multimodal models that integrate not only text but also vision and audio?
I think that the metrics and the overall guardrails in their principle will stay the same, but the details might be different because for example, there are so many prompt injections and bypassing that are happening in image generation. People are becoming crazy. If you enter Reddit and there is a specific channel where we call it imagery prompt injection, I think, and people are just getting really creative about how to bypass the guardrails of OpenAI and Gemini and all the providers that make image generation, and they are really generating some crazy stuff. And this is because of not really, because you can't, in fact, you can't really implement 100% effective guardrails. There's always 1% that you miss, and this is why also we see Google making competitions for hackers to generate some specific content they want to see, just in order to monitor their LLM and see how good their guardrails are. But I think, yeah, I think the principles stay the same. I don't know. I never saw the guardrails about vision specifically or videos, but I am sure they are the same because you always are manipulating some text.
Yes. And I also believe that both vision language models and LLMs, they like share the same architecture, which is
Yep.
transformer. So they are trained basically similarly using the same architecture and the same techniques. So securing them and also building efficient apps or choosing efficient VLMs or LLMs could apply the same rule could be applied to the same rules, but with more specific cases for vision language models.
Indeed, indeed.
Yeah,
You summarized everything. Thank you, Wael, for this amazing event. I really
yeah.
enjoyed it. Thank you for
Thank
your
you.
thanks for your hosting. That was quite nice. Continue,
Yeah,
School of AI. You are doing amazing stuff. I really enjoyed all your events before and even now, and maybe in
yeah,
the future we will see. We will see what you will do in hike.
yeah.
Amazing.
Thank you very much, Azzedine, for coming,
You're
for
welcome.
enlightening us. Yeah, it
You're
was
welcome.
our honor, our pleasure to have you with us today,
Thank
and
you.
yeah. And thank you everyone for coming and today's session. And see you tomorrow, inshallah, with another online conference. Thank you,
See you.
Hussein, and see
Bye
you
bye.
tomorrow.
Assalamu alaikum.
Saha.